One of the most important questions that humanity has ever asked is, are we alone in the universe? Is there life on other planets? If so, what kind of life is it? And what if that life is not only alive but also intelligent and technologically advanced? How would we communicate with it? These are some of the questions that have captivated humanity for centuries, and that might now be answered by one of the most powerful and ambitious scientific instruments ever built, the James Webb Space Telescope. In this video, we will explore what might be the most important discovery in the history of humanity, which is what could be biosignatures and technosignatures on the exoplanet K218b by the Webb telescope, and what it means for the search for life beyond Earth. We will also explain how James Webb detected these signs of life, and how it could do the same for other planets in the future. This is a groundbreaking discovery that could change our understanding of ourselves and our place in the universe. So stay tuned and don't miss this incredible story. K218b is an exoplanet that was first discovered in 2015 by NASA's Kepler Space Telescope, which detected a slight dimming of its host star as the planet passed in front of it. The planet is about 2.6 times the size of Earth and about 8.6 times its mass. It orbits a red dwarf star called K218, which is much smaller and cooler than our Sun. The star is located about 124 light-years away from us in the constellation Leo. That means that the light we see from K218 today left the star when Napoleon was still alive. But what makes K218b so interesting is not its size or its distance, but its potential habitability. The planet lies in the habitable zone of its star, which means that it receives enough heat and light to allow liquid water to exist on its surface, if it has one. Liquid water is essential for life as we know it, so finding a planet with water is a big deal. But water alone is not enough. The planet also needs to have an atmosphere that can protect it from harmful radiation and regulate its temperature. And that's where things get even more exciting. This planet has a hydrogen-rich atmosphere, which could indicate the presence of water vapor and other gases that could support life. In fact, some previous studies using Hubble and other telescopes have detected water vapor and hydrogen cyanide in its atmosphere. Hydrogen cyanide is a toxic compound on Earth, but it could also be a building block for amino acids, which are the basic components of proteins and life. So, K218b is a planet with water and a hydrogen-rich atmosphere in the habitable zone of its star. That sounds pretty promising, right? But there's more. This planet could also have a water ocean under its thick atmosphere, which could provide a stable environment for life to thrive. And not just any life, but possibly complex and diverse life forms that could rival those on Earth. How do we know that? Well, that's where James Webb comes in. One of James Webb's main goals is to study exoplanets and their atmospheres and look for signs of life on them. These signs are called biosignatures and technosignatures. Biosignatures are molecules or features that indicate the presence or activity of living organisms on a planet. For example, oxygen is a biosignature on Earth because it is produced by plants and algae through photosynthesis. Technosignatures, on the other hand, are signals or artifacts that indicate the presence or activity of intelligent civilizations on a planet. For example, radio waves are a technological signature on Earth because they are produced by humans through communication and broadcasting. James Webb has been observing K218b since early 2023, and what it found was astonishing. It discovered carbon-bearing molecules like methane and carbon dioxide, which are products of biological processes on Earth, as well as possibly dimethyl sulfide, which is a product of only life on Earth. Dimethyl sulfide is a sulfur-containing compound that is emitted by marine algae and bacteria and gives the sea a characteristic smell. It is also involved in cloud formation and climate regulation on Earth. Finding dimethyl sulfide on this planet could mean that there is a similar cycle of life and climate on the planet, and that there are oceans full of living creatures. But that's not all. Webb also discovered chlorofluorocarbons and nitrogen dioxide, both of which are byproducts of human activity on Earth. Nitrogen dioxide is a pollutant that is emitted by cars, factories, and power plants, and contributes to smog and acid rain. On the other hand, chlorofluorocarbons are synthetic chemicals that are used in refrigerators, aerosols, and air conditioners, and that damage the ozone layer and increase global warming. Finding the compounds on K218b could mean that there is an advanced civilization on the planet and that they are facing similar environmental challenges as we do. So, what do these findings suggest about the nature and origin of life on K218b? Well, there are several possibilities. One possibility is that life on this planet is similar to life on Earth, and that it evolved from simple to complex forms over billions of years. Another possibility is that life on this planet is different from life on Earth, and that it has a different chemistry or biology. A third possibility is that life on this planet was seeded by life from Earth or another planet, either naturally or artificially. A fourth possibility is that life on this planet is not native to the planet, but was brought there by aliens or humans who colonized or visited the planet. Of course, these are just speculations, and we need more evidence and research to confirm or reject them. But one thing is clear: K218b is not a typical exoplanet. It is a Hycean exoplanet, one of the most promising environments to search for life outside our solar system. Hycean exoplanets are planets that have hydrogen-rich atmospheres, watery oceans, and moderate temperatures. They are more common than rocky planets like Earth, and they could host a wide range of life forms, from microbes to animals. This planet is the first Hycean exoplanet where we have detected biosignatures and technosignatures, but it could be just one of many. Now you might be wondering how James Webb was able to detect such faint and subtle signs of life on a planet so far away from us. Well, it was not easy. It took a lot of time, effort, and ingenuity to achieve this feat. Webb used a combination of methods and techniques to observe and analyze the atmosphere of K218b. Here are some of them. First, Webb used its NIRSpec instrument to obtain high-resolution spectra of K218b as it transited in front of its star. This technique is called transit spectroscopy, and it allows us to measure the amount of starlight that passes through the atmosphere of the planet at different wavelengths. By comparing the spectra before, during, and after the transit, we can infer what molecules are present in the atmosphere and how much they absorb or emit light. Second, Webb used a computer model to simulate the sensor capabilities of JWST and identify the key molecules in the spectra. This technique is called synthetic observation modeling, and it allows us to test different scenarios and hypotheses about the composition and structure of the atmosphere. By comparing the simulated spectra with the observed spectra, we can determine which scenario best matches the data. Third, Webb used a statistical method to estimate the probability of detecting biosignatures and technosignatures on this planet. This technique is called Bayesian inference, and it allows us to update our beliefs based on new evidence. By using prior information from previous studies and observations, we can calculate how likely it is that we have detected true signs of life or false positives. These methods and techniques are not perfect, though. They have some challenges and limitations that need to be considered. For example, the starlight from the star K218 is very faint and variable, which makes it hard to obtain clear and consistent spectra. The atmosphere of the planet K218b is very thick and cloudy, which makes it hard to see through it and detect its features. The biosignatures and technosignatures on this planet are very weak and mixed with other molecules that could have non-biological origins or explanations. These challenges and limitations mean that we have to be careful and cautious when interpreting the results of James Webb. We have to consider all the possible sources of error and uncertainty, and to look for independent and complementary evidence to confirm or reject our findings. We also have to be open-minded and humble, and to acknowledge that we might be wrong or incomplete in our understanding of life on other worlds. This is a groundbreaking discovery that could change our understanding of ourselves and our place in the universe. It could also open new possibilities for communication and cooperation with other intelligent beings, or for exploration and colonization of new worlds. But it also raises new questions and challenges that need to be addressed by science, philosophy, ethics, and politics. How do we define life? How do we recognize intelligence? How do we protect diversity? How do we share resources? How do we coexist peacefully? These are some of the questions that we will have to face as we enter a new era of cosmic discovery. Thank you for watching this video. I hope you enjoyed it and learned something new. If you did, please like, share, and subscribe for more videos like this one. And if you have any questions or comments, please leave them below. We would love to hear from you. Until next time.